with a physical classroom in Bangalore. Uh, all of our professors flew down and taught a bunch of students like yourselves for 15 days. They actually packed in the entire syllabus or a lot of the syllabus of the Master AI program into a very, very short period of time. And some of those people who actually did that program with us are today on this session as one of your several TAs. So we'll be introduced to them very soon, but let's waste no more time. I'll have you over to Rahul, who is going to be your primary faculty member for this program. For as you, for those of you who continue on to the master programs or accelerated programs, the next course is going to be taught by Pavlos. And so over to you, Rahul. Let's get started.
Thanks, Siddharth. Hello, everybody. Good number of you have actually signed on to the Slack channel. Welcome over there. And those who haven't, please do sign on to that Slack channel. It's going to be our main chat communications channel rather than the Zoom channel. So please do sign on when you get a chance. So let me start off by actually sharing my screen here and talk a little bit about us. So here we go. And I should probably just share this desktop. Okay. So I'm gonna go over. Can everybody see my screen here? It should probably be on Univ.AI programs. If you don't, please tell me so that I'm not.
Visible. Yep, I can see it.
It's visible.
Okay, thank you. Thank you, folks.
Full screen, please, Rahul.
Pardon me?
Full screen.
Are you okay? Full screen, good idea. Okay, here we go. So let me just very briefly talk about our program. Our program takes you through the very beginnings, which is this course, Foundations for AI, all the way through fairly complex stuff in Master DSE and Master AI. You can look at the details on the website, but I sort of wanted to make the point that this is if you like a train, and this is the first stop on the train. Having said that, it's going to actually be an incredibly interesting first stop on the train. We're going to learn how to program in Python, and we're going to take this learning of programming in Python all the way to actually writing a neural network library on our own. So it's going to be quite a ride. It's not going to be easy, but it's going to be a lot of fun. So let me point you to the email that was sent out today, and it pointed you to this website, welcome to Univ.AI, where there's a welcome message which you can read at your leisure on the homepage. But if you click on Foundations over here, it will take you to a detailed set of information about this course. And when I mean detail, it's really, really quite detailed. So there's a lot of things to read over there. The most important things, however, are when we're meeting, and that's going to be 7:30 to 9:30 p.m. Thursday and Sunday. We just decided to have this sort of introductory meeting earlier so that we can get some things out of the way before we start the class in real earnest. So 7:30 to 9:30 p.m. Thursday and Sunday. We'll start pretty much on the dot or at most 5 minutes late. Those who know a little bit about me know I taught at Harvard, and at Harvard we had this thing called Harvard time, which always meant that every class at Harvard never started at 7:30 p.m. if it was supposed to start at 7:30 p.m. It always started at 7:37 p.m. And that was because people had to walk from one class to the other across campus, and that was the reason for that. So we'll start between 7:30 and 7:35, a little bit of 5 minutes to get people in, but then we'll start at 7:35 sharp. Okay. So 7:30 p.m. to 9:30 p.m. Thursday and Sunday lectures. We'll have office hours with me on Wednesday and with our TAs on Friday, Saturday, and Tuesday, between 7:30 and 9:30, except on Tuesday, where it's between 8:30 and 9:30. So this means that there's, besides the 2 lecture days, there are 4 other days in which you can have some connection, some contact with us. And if you like, Monday is the only day where we don't actually get to see each other if we don't want to see each other. So please take advantage of this. I don't think you'll find mentorship of this level and of this frequency anywhere else. So you should definitely take advantage of it to get as far ahead as you can in your, in your work. Okay, so really the most important things I need you to do at this particular moment are twofold. When I was looking at the signing up on our website, I noticed that most people have not connected their GitHub IDs to their Univ.AI accounts, and that's really important. And I'll tell you why it's important. All of our course material will be made available to you via GitHub, and if you don't have a GitHub ID and you don't give us that GitHub ID, there's no way we can add you to the GitHub organization representing this course. And so there's no way we can actually get the course material over to you. So it's fairly critical that you do it. There are very detailed instructions over here with pictures on how to do it. So please go ahead and do that today. I'd really like everybody to have this ready by class tomorrow.
So Rahul, how much time does this take to do?
To connect to GitHub, a minute at most.
So why don't we take a 2-minute pause and have most people connect to GitHub?
Sure, we can do that.
Yeah. So folks, use that link, figure it out, and just do that, because that gets one major thing out of the way. Nikhil, you've just entered the room. Can you hear me? You can unmute and talk to me. Nikhil? All right, we'll wrap up in another 30 seconds and move on.
Yeah, and if you're having problems with any of these things, please get on Slack and talk with us on Slack, and we can figure out what the problems are and help you so that by your class tomorrow you have this all set up.
So if you're wondering why we have so many forums, there is a Telegram that you use to communicate with us for all administrative matters, right? So if you have trouble, if you need help with the non-teaching staff, just reach out on Telegram. If you have any courseware related questions, for that there is Slack and there is Discourse, for which Rahul will explain which for which. Sirish is asking which channel on Slack is for general queries. Is it the water cooler one? Is there
Yes, it is the water cooler one. I have a fairly detailed page on Slack over here, which tells you what everything is for. So you'll see over here, it says water cooler is for just chatting. All suitable for work, subjects acceptable here. If you want to put pictures of your kids or whatever you want to do, I mean, I have kids. You can put them up here if you like. There's homework for homework conversation, project for project conversation, office hours for office hour coordination, and lecture for within lecture logistics and question collection. We'll talk about that a little bit more next time about the lecture thing. Actually, I don't think I've added that. Once I'm going to actually go add that channel while we're at it. do that. Create a channel. Okay, it's done. Okay, so let me move on in the interests of time. So there are two very critical things you need to do over here. One of them is to connect your courses account to GitHub, which I hope some of you have already done. And then the second thing is you want to log on to the discourse.univ.ai forum software. There are again instructions which you can click on from this welcome site over here, telling you how to do it. It's actually quite simple. If you go to Discourse and you just click up either the sign up and login things, it'll redirect you to our website, courses.univ.ai, and walk you through the whole process. So it'll look something like this. So if I'm using my hey.com email address, rahul.hey.com, it'll basically get my username out of Univ.ai and plunk it in here, and it'll make my name the same thing. You may want to choose a name which is somewhat more readable rather than Rahul.hey. So for example, I say Rahul Hey Dave here. And then just create a new account and you're done. Siddharth, did you just mute me? Okay, so I don't know what portion of this you guys might have missed, but what I was saying was if you create a new account, choose a name out here, then hit create new account, and you should be set up. And the reason to do this is that we have forums for this course. You will not see them right away because you're not signed up for, I haven't added you to the group for this course. But the faster you do it, the better, because then I can add you to the group for this course and we can all chat on the forum. So let me talk a little bit about the forum here and why forums are important. I do kind of write it in great detail on this webpage. But the important thing out here is we can do a lot of our questions and answers, for example, via Slack, or actually by just picking up the phone on video conferencing or doing any of these kind of things. However, that information is very ephemeral. It's lost, right? Say, for example, Shirish and I are talking and we have a conversation and it's something about how to refactor code. And then it's just between the two of us. It's lost to the rest of you. So it's almost better if you actually ask questions on the forum because everybody can benefit from it. So you'll get a lot of good karma by doing that. But it's also better from the perspective of, from the following perspective. I've often found when I'm on forums and stuff like that, and I'm sort of formulating a question, the answer to my question formulates by itself because I have to be a little bit more precise in writing stuff to ask that question. So there's an intellectual exercise that you go through in sort of writing the question in a way that somebody else can understand, which you don't necessarily do when you just say it from your mouth. And it's the same thing with me. I often find that when I'm creating teaching material, my understanding of the subject becomes better. And the reason for that is because I'm forcing myself to get to the nitty-gritty of what's important about the subject, and my understanding always improves. So, teaching is a great process because it actually helps me more than it probably helps you, because my understanding of the subject increases. So that's the reason why I strongly encourage you to actually write things onto Discourse rather than just putting questions onto the Slack channel. Having said that, there are times when you want a clarification or something of that sort, but the Slack channel is a much better thing than Discourse. And we've actually connected the two together, and I'll show you this later on. That we can actually have a bi-directional connection. If somebody's asking a question on Slack, you can point them to an answer on Discourse. And if there's a bunch of conversation going back and forth on Slack, which is germane to an answer on Discourse, we can actually just transport it from the Slack to the Discourse automatically. So we'll see how to do that, as time goes on. So please do these two things. Then the third thing, which is really kind of important, is that you need to fill out the form. So the URL for the form was sent to you in the email clearly I don't want to put it on the website. Otherwise, some spammer is going to get a hold of it, and we're going to get funny things showing up here. So that's in the email we sent you today, and that email is just basically a Google form. It has pictures of all the account information that you want to take, and I think I can show you this form. Let me go to it over here. I think it's on.
So some people had emailed that they were having trouble with the form. Was that all resolved? It had restricted access, then we opened access to it. So if anyone still has a problem with the form, drop a message here or on.
Yeah, and we can figure that out. Yeah, here it is. So can you see the form here? So it's basically asking you what email you signed up for Univ.AI with. What's your Univ.AI username, which is in the upper right corner at courses.univ.ai. Your GitHub username, which you can either get from the profile. The profile itself you can obtain by just clicking on the upper right corner where your name is. Or, given that you signed up at GitHub, you can probably go to GitHub and get it. So that's the next question. So you can put that answer in here. And then finally on Discourse, it's a little bit probably the most complicated place. This little icon after you signed in on the upper right corner, if you click it, actually has has your username on it, so you can pick it up from there. And then just hit enter, and this information, as you know, with Google Forms, comes to us in a nice spreadsheet. I'll take that information in a spreadsheet. I will open up the spreadsheet using pandas and Python, and I have automatic Python program which will add you to Discourse, which will add you to GitHub, and all of these kind of things. So that's, yeah, it'll be fairly simple, and then by tomorrow you'll have access to all of these things. Okay, so let me see, where was I? I was here. So that's the third thing, which is absolutely critical to do. Finally, there's a fourth thing that's absolutely critical to do. That's installing Anaconda Python on your computers if you don't have it installed already. It's pretty important that you actually install Anaconda Python in the 3.7 version rather than the 2.7 version. You might have a 2.7 version of it on your computers, from the perspective of a class that you've done in college, or for whatever other reason. Python 2.x is end of life now, so you need to go to Python 3.x. Everything we'll be doing is in Python 3.x. So again, I provide a detailed link over here. There's 2 videos that Akshaj has recorded on how to go and get the packages. There are links to where you can pick up the packages from Anaconda's website. Be careful to get the 64-bit versions. Almost all our computers now are 64-bit versions. If you have a 32-bit computer, that's a bit weird. But let us know about it if that's the case. So it's 64-bit version of Python 3.7 for Windows, Mac OS, and for Linux. If you are on Windows, I strongly recommend that you also install a piece of software called Git Bash. But I will send more information about this out. We don't need it right away in the course. Okay. So yeah, this page goes into a good amount of detail on how to start Anaconda up, and how to actually get the Python user interface up, and then type something like 1+1 into it, and make sure that 1+1 gives you 2. And please let us know if it doesn't give you 2, because something is really wrong with the universe if 1+1 is not giving you 2. So there's a little bit more about Python over here, which you probably want to read before class tomorrow. It's not, you don't need to do it, but it'll help you along the way. So good thing to do. I just put it all on this web page. This last piece of it is probably important to read about Python's colon indentation. If you're not familiar with Python, one of the weird things about the language is that it doesn't use braces like Java or C++ or C or any of these languages. It uses indentation. And the first time I saw that, I ran away from Python as fast as I could possibly run, because I'm old enough that I used to program Fortran at some point, and Fortran used indentation, and I had scary problems with getting my indentation wrong in Fortran. Turns out that Python's actually much nicer about it, and the indentation makes code way more readable. So I think you'll actually end up enjoying it after a while.
Rahul, we have a question here.
Yes.
It says, can we use Google Colab?
Can you use Google Colab? The answer is no. you want to use, you want to install Anaconda Python because this course is really about software development. And Google Colab lets you program in Python, but doesn't actually let you do any real software development. One of the things we're going to actually show you as to how to go from Jupyter Notebooks onto Python files, how to refactor code between Jupyter Notebooks and files, so that stuff which should be in libraries actually gets into libraries, and stuff that should be in Python notebooks gets into Python notebooks, into IPython notebooks. So the answer is probably you could get away with using Google Colab for the next 1 or 2 lectures, but after that, no. As you get a little bit more advanced with some of this stuff, you can use Google Colab and might have to use Google Colab from the perspective of the GPU access that Google Colab provides you. But that's not germane to this course at all, because nothing we do will actually require GPUs to that extent. We will be doing some neural networks at the end of this course, because after all, we are writing a neural network library, but the problems we solve will be doable on CPUs. We designed it to be like that so that you don't have to worry about GPUs over here. So these are the main things which I kind of want you to do. The next thing is, well, get on Zoom. Clearly, you've already done that, so I don't need to say much about it. Again, there is detailed instructions. And one of the instructions that will actually become kind of important are these things called breakout rooms, because that's where I'll be doing the labs. And at the end of our session today, I will go through a exercise in which we'll all get into different breakout rooms and do stuff over there. And so that will lead that session. So we'll talk about that. There's detailed information about breakout rooms in the document on Zoom that I put up on the website. I strongly recommend you read that to get an idea of what's going on before tomorrow. Okay, so that's Zoom. The next thing is Slack. So Slack's kind of nice from the perspective of chatting, but it's also nice from the various interactions it gives with everybody else. So I'm going to get a, can somebody who's on Slack just tell me their name? And because I don't know if everybody on Slack is actually on over here. So let's see, let's just pick somebody. Anshuman, are you here?
Anshuman isn't here tonight.
Anshuman isn't here tonight? Okay. Let's see. Saurabh?
Yes, I'm here.
Yeah. Okay. So if you will unmute yourself, let's actually try a few things so that people can see how this works. So what I'm going to do, can everybody see my Slack screen?
Yes, sir.
Yeah. Okay. So there are different channels in the Slack screen that we can use. There's the water cooler channel where we can just talk about anything we like. So I'm just going to say, hello. The first kind of thing you may want to say on a Slack channel. Well, not really, but if you ever written a C program, you know you always write hello world first. So there, I'm just going to put hello world on there, and you can respond if you're already on Slack, and if not, that's fine too. Now, the next thing you can do, and you can do this with each other in a very simple fashion, is to, for example, do a little video conference. So, Saurabh, let's do a quick video conference over here. So I'm just going to type Jitsi over here, which is the other video conferencing software. Okay. And I think I can just have to do Jitsi Saurabh, or I think I can do just Jitsi in this, in this private message over here. And that's basically going to give us a little join channel. Let's see if we can explode the internet right now by actually having a video conference shared over another video conference. So I'm going to try and join this. So Saurabh, if you can join this as well. It should work directly out of your browser. You shouldn't have to do anything else. There we go. Saurabh is on. I'm on, and we can talk with we can talk with each other. I think we might break things if we try and do video. Maybe we should do a video conference inside this video conference. No, I'm just kidding. We could share the screen using Jitsi, and then try and do another Jitsi inside of Jitsi. And by this point, we'll have an infinitely recursive process, and things will blow up. But thank you, Saurabh. I just wanted to show you that you can very easily and quickly. Thank you, sir. get together with whoever you want to talk with, or with one of us, without necessarily being part of the Zoom, which we're going to use in our course. Bye, Saurabh. I'm gonna sign off. So that was Jitsi. Very quick way. Just type /Jitsi in your Slack channel, and you can do that. And one of the reasons to do this is if you're in an office hour with a teaching assistant, you can probably very quickly just get a little 1:1 conference going on very fast with that teaching assistant. So we'll figure out what's our exact mode of working for office hours. We haven't quite figured it. One way to do it, maybe just to have a Zoom conference where everybody is working. Another way to do it is to perhaps go on the office hours channel. I do strongly recommend that for office hours, you pose your questions ahead of time on the office hours channel, because it quite often happens that many people have the same question. And if many people have the question, they can say +1 or me too or something of that sort on that channel. And then we can direct the office hours a little bit more in that direction. Does that make sense? Zoom. Let me see. All right. Okay. So that was the next thing. So let me go back to my welcome software here. Yeah. So for office hours, and I'm not going to demo the notebook pad today, or all the exercise and test system today, or the platform, except just very briefly to talk to you about the platform. But those are some of the other things over here. So let's see. Let me just go over the things we needed to talk about. We needed to talk about GitHub. We needed to talk about discourse. We needed to talk about filling in the form. We needed to talk about Anaconda installation. You're already on Zoom, so we don't really need to talk about that, but we're going to do breakout rooms in a little bit. We needed to get on Slack. Hopefully a large portion of you are on Slack. Those who are not, please join up. Okay, so then we have the breakout. We have what's left, the platform. We're going to talk about that, the breakout. But I wanted to spend a little bit of time talking about the course. And you can see more about the course on this page if you click, or if you look, if you like, further down. So here's some information about the class. So the structure by which we're going to do these classes are mainly lectures. And some lectures, like for example, tomorrow's lecture won't necessarily have labs or interwoven in, but tomorrow's lecture is basic Python. So we're actually just going to be working on it all together. So the entire lecture is going to be a lab. But if the entire lecture is not a lab, we'll actually have labs interwoven in. And we'll do that in breakout rooms, supported by a professor and TAs. And we'll come to breakout rooms in a little bit. Every lecture has an accompanying Jupyter notebook. Sometimes you might have more than one notebook, and every lecture has slides. So you'll have slides and Jupyter notebooks for every lecture. Every lecture has some exercises after some sections. You are expected to do these exercises in class. A good portion of your grade is participation. You're not expected to get these exercises correct at all. It's important to actually just try them out, and to try them out again and again. Correctness is of secondary importance. You'll eventually get them correct. Nobody cares if your answer is right or wrong. We all care about you trying stuff out. That's really the important thing, okay? And that's a general theme through this course. You're probably going to be wrong more times than you're going to be right. And that's perfectly fine. That's the only way any of us learn anything. Okay, so that's lectures. Then homeworks. There's a homework every week. Has a maximum of 2 questions. And it should take you about 7 to 8 hours to do. So this is a fair bit of work. It's not, I won't lie, it's not a little bit of work. But here's my guarantee to you. Here's my promise to you. This is where most of the learning will happen. It's in the homework. It's in talking to each other about the homework. It's in asking questions about the homework on the forum. It's in talking to us about the problems you're encountering in the homework, where most of your learning is going to happen. So it's really key that you do that. Okay. And as I said, there's copious amount of mentorship. You can ask questions on Slack at any time. You can ask questions via discourse at any time, and we'll probably get back to you sooner rather than later, or very likely a fellow student may get back to you faster than we will, and if the fellow student is correct, we will endorse their answer. Okay. So, but remember, try and put the questions on discourse first and then on chat afterwards, because that will help everybody. So we have some policies around collaboration and grading. Those policies are listed over here. I won't get into them in any detail, but I just want to point out to you that you can find this information on the website here. There's the whole idea of how much grading. There's 3 homeworks. Each one is 15 points. The project is 30 points. The quizzes have 5 points for correctness and 10 points for participation. And you're allowed to do quiz questions again and again and again. So basically, you are going to get those 5 points for correctness. So don't even worry about it. And other participation is 10. This includes participation in class if we ask questions. And most importantly, participation in the discussion forums. So in other words, if you're answering somebody else's questions, you're getting points. So don't forget to do that. I don't know, actually, it's not a 5-point scale. This is a 4-point scale. Clearly, I cannot count. Your grade will roughly be in kind of these these buckets. We expect most people to get an A-, and the most excellent amongst you will get an A in the class. We really don't expect many of you to get a B+, and we expect nobody to get a B over here. So collaboration policy, this is important because in regular kind of courses that you might do in college, you can't collaborate. Here, the idea is totally different. You can collaborate as much as you want. You can work together in groups on homeworks. You can do it by yourself if you like. That's minimum 1 person. A maximum is 3 people because trust me, about 3 people, group collaboration dynamics go really bad. Usually what happens is after 3 people, 1 person is a freeloader and 1 person is doing too much work. It just doesn't work. So 1 to 3 people is actually a good size. However, each one of you must submit your own homework. So if you worked with 2 other students, all 3 of you should just submit identical copies of your homework. And you must mention on this homework who you collaborated with. But besides that, to do this homework, all 30 to 40 of you could work together. When I was in grad school back at the University of Pennsylvania for physics, we would spend maybe from 8 o'clock in the evening to 8 o'clock in the next morning sitting together in a room and trying to figure out what was happening in the questions. And I promise you, I actually learned more physics from talking to my fellow graduate students than from professors. So it's really kind of important to talk with each other about this. Put the questions up on the discourse. Our idea is that everybody gets full points on the homework by talking to each other about it. So, in this kind of scenario, the temptation is to freeload a little bit. Let somebody else do the work and then just pick it up from there. You'll get your grading points, but you won't get anything out of it. Freeloading is not a useful thing in life. Getting the grade is not the important thing. Learning is the important thing. If you don't learn, then when you do subsequent stuff, you'll be in some kind of I don't know, maybe the right word is technical debt over there. So don't freeload. Do stuff. Try and understand stuff, even if you're copying it from somebody else. That's really, really the point. If you do copy from somebody else, please attribute that you did that. That's kind of important because it's very easy to figure out that you copied code from somebody else. And if you haven't attributed it, that's kind of like a bad mark on you. So please don't do that. And then the regular stuff. All of us go to Stack Overflow and get code. Every highfalutin machine learning and neural network researcher picks up 20% of their code from Stack Overflow. So it's perfectly fine to do it. Just attribute what you picked up from Stack Overflow. That's kind of important. Okay. Here's other stuff about deadlines and late dates and all, and you can kind of read it yourself. I'm not going to go into it in any more detail. So our schedule is here on this page as well. It's also on the top level page. And the sort of important thing about the schedule over here is to kind of realize, so let me actually give myself a little bit more space on my screen before I talk. That will release homework 1 this Sunday. And that's why at the end of at the end of lecture 2. And every Sunday at midnight, roughly speaking, we'll basically release a homework. And then it's due at 5 p.m. before the lecture the next Sunday. The reason that it's due before the lecture is we don't want you to not be at the lecture because you're doing homework. That's kind of a bad idea. So that's sort of like our point over there. Nothing terribly complicated from that perspective. If for any reason we get delayed in releasing, we'll also sort of clearly make the submission date a little bit later. So yeah, so here's kind of the schedule. There's a project, and the project will be released on I think it's going to be 26th of July. You have a little bit more time to do it all the way up to the 4th. The project's a little bit longer than a homework, but not hugely longer. It's a little bit harder than the homeworks, but not hugely harder. And you'll actually be solving a real world neural network problem in it using code that you've written on your own. So it's actually going to be fun. Speaking of which, let's go and talk about that. So what is actually in our, what are we actually going to talk about in this class? So let me see, where I put that somewhere. Let me find out where I did put that. You can see a more detailed schedule with detailed topics. Here you go. It's this web page over here. Again, I have the schedule put up, and I have a week by week notion of lecture. So this is where all the fun is. So I might as well talk a little bit about that. So what are we going to do in this class? We are going to learn how to program in Python from the very beginning. And we're going to write a neural network library at the end. Here we go, in lecture 8. So how do you do that in 4 weeks? Not easy. It's kind of hard. It's a lot of work, but I think it's going to be a very fun journey to get from one place to the other. So what we're going to do is we're going to start off with Python on lecture 1, which is tomorrow. You're going to get sort of like comfortable with strings, files, dictionaries, classes, that kind of stuff. You're going to get comfortable with Anaconda and Jupyter Lab. So that's why I strongly recommend that you install Anaconda, get familiar with it before you come to class tomorrow. We're not going to be spending time doing that in class. So you definitely want to do this installation before you come. If you have problems, put them on Slack. Put them on the, I would actually put them on Slack right now rather than on Discourse, because it might take a little bit of time to get you on Discourse. So put it on Slack and we'll answer your questions over there. Okay. The second lecture talks about vectors. You've done vectors back in school. Maybe you remember them, you know, the I hats and the J hats and the K hats. We'll talk about these mostly in connection with how we're going to implement a vector class in Python. So that's what we're going to do in lecture 2. Okay. We'll have a homework, and the first homework will be relatively simple. It will just be a notion of sort of like doing something with cosine similarity. Then we'll go to lecture 3, and lecture 3 will go a little bit more into Jupyter Lab. We'll introduce you to the terminal in Jupyter Lab, because if you're going to be as a data scientist, a machine learning engineer, machine learning scientist, or a deep learning person, you have to learn how to use the terminal, whether it's the terminal in Windows and on the Mac or on Linux. It's kind of important. We'll do a little bit with pandas, and then talk a little bit about some statistical visualization concepts. In lecture 4, we'll dive deep into some probability and statistics. Random variables, sampling, Gaussian distributions will actually predict elections. That's what lecture 4 is going to be about. I will also show you how to control your computational environment using Conda. Anaconda actually has a tool inside of it called Conda, which can install just the right amount of packages for you, and thus make your computation reproducible. So that's what we're going to show you over there. So you'll notice that in each one of these lectures, there's a little bit of Python, there's a little bit of statistics, mathematics, that kind of stuff, and there's a little bit of computational stuff. By which I mean not just like Python language stuff, but things like how to use computational environments, or how to do things like using terminals and stuff like that. In week 3, we'll start writing our Python library. And we'll talk a little bit about gradient descent, which is the first time we'll see some calculus. and how minimization is done, and why on earth is this minimization process coming about. And we'll see that from the perspective of something in probability theory called maximum likelihood. Okay, so the next thing is we're going to dive a little bit more into this library. We're going to refactor this library. Refactor is a word which means write your code in such a way that you can improve it incrementally from one point to the other. So we'll be using software development techniques that we'll actually learn this Sunday to refine our implementation. We'll move from 1D calculus to 2D calculus, and from functions of one covariate to functions of many covariates. I go into multiple dimensions. If you're relatively new in college, you have probably not done this, but if you're not a freshman, you probably have. So we'll go into that in great detail, and we'll keep refining our library. And finally, in lecture 7, which is the last week, we'll actually go off into some core machine learning concepts, and we'll come back to vectors and matrices, because these machine learning concepts will come back into an understanding of matrices. And people love to talk about artificial neural networks and AI and all this stuff. All these are big words. It's basically matrix multiplication. You've done matrix multiplication. If you can do matrix multiplication, you can do neural networks. So you should feel confident about it right now already by my saying this. So we're actually going to talk about the matrix multiplication part of neural networks and the kind of geometric intuition of it. We'll see that the simple minimization and maximizations we were doing earlier no longer work. So we're going to have to come up with a stochastic technique to do these optimizations, and this is called stochastic gradient descent. And then finally, in lecture 8, we'll see that the stochastic gradient descent stuff will require us to make data, to actually give data in smaller bits to our optimizer. So we'll go back to Python and talk about interesting Python concepts behind yield and generation. And then we'll go off into sort of like the matrix algebra of neural networks and unravel the geometric intuition behind that. And finally, you'll sort of like package up your kudzu library for other people to use. And then you'll actually use it in a homework. So that's the structure of that. So I think it's a good point for me to stop sharing my screen. I think I've actually said everything that I wanted to say over here. But I really want to exhort you to get your Discourse account, get your GitHub account, fill in that form, so that I can set you up really fast. And I think I'll just turn it over to Siddharth to talk about sort of like breakout groups, and then we're done. So let me stop sharing my screen, and you can see my you can see my lovely face again. Siddharth, let me turn it over to you.
Well, I thought I'd also take a moment to introduce our TAs. So Rahul, I think.
Oh, that's actually a great idea. Why don't we do that first before we go off to the breakout groups? Yeah.
So let's go in order, alphabetical order. Or maybe the head TA first. Varshini, are you around?
Yeah.
All right.
You want me to turn on my video or something?
Of course. I mean,
yes,
okay, then let's go alphabetical order while I turn on my lights.
All right. Then Varshini comes later. And any video on volunteers while Varshini gets herself ready for a video on session? Anusha.
Well, let's go alphabetically then. Akshaj is here. Akshaj, you want to turn on your video for a second?
Yeah, sure. So hi everyone, I'm Akshaj. So I'm currently a master's student at Carnegie Mellon, doing my master's in AI and innovation. And I'm currently researching in connecting AI and law and AI and philosophy. So the thing is that I'm studying the implications of AI systems. So let's say YouTube has a recommender system, right? So it normally divides people in a politically biased way. So I'm researching on stuff like that. So if you are interested in that, you can contact me. And if you have any other questions regarding how to get started, any questions, you can contact me. Yeah, that's it from my side.
All right. Where is that? Is Anusha here tonight or not?
I see Anusha here.
Okay.
Oh, I have to switch on my video. Okay.
Yeah, that too.
Hello. Hi, everyone. My name is Anusha. I'll be your TA. for this course. And so I basically have a bachelor's degree in electrical, and I'm currently working with Univ.AI, and I also work on electrical plus AI applications in electrical engineering. So that's my background. Nice to meet you all.
Varshini?
Can you see me?
Yeah, we can.
So
Okay, I was
just add that Anusha is Georgia Tech bound
Yeah.
once this whole COVID thing blows over.
Yeah.
Well, I'll be your TA for this course. I basically work with cybersecurity and graph theory. I'm Varshini, by the way, in case you did not realize that. Yeah, hope to see you guys more often. Please do join the office hours. I'll be there.
Varshini is the head honcho for this course, just so you know.
Yeah, just
So
so
listen
you
to
can
her.
add a little more pressure, but yeah.
And Varshini also would have been graduate school bound were it not for other situations. She was supposed to be heading to Harvard or a galaxy of other institutions. I don't know which one of them. But so off to Arya.
Yeah, hi guys. So I did my electronics undergraduate, and I'm actually alumni of Univ.AI as well. And I just want to say that you guys have to take like advantage of this course because they're incredible teachers. And yeah, please reach out to me if you guys have questions.
All right, who do we have next? There is
Uh,
Tejas and Rohit, right?
Tejas and Rohit, yeah.
Yeah, Tejas.
Hey, hi guys.
You're not visible.
Hi guys. Yeah, can you see my
There
video
you
now?
Yeah, it's very pitch
Guys, I'm
black.
Tejas. I work as a data scientist with MoneyTap. It's a financial tech company that lends out loans. So I kind of deal with all credit-related scoring activities and everything. I build models and predict whether users are going to default or not. So that's my background. I was a part of the Univ.AI course last year, and that's how I joined these wonderful guys over here, and I look forward to interacting with all of you during office hours and otherwise as well.
And I don't know if Rohit Goswami is here. Is Rohit here? I thought I saw him join.
He might have.
Okay, all right. So it looks like, guys, Rohit is not here, right? But
He was here. I think he had his lab session to go back.
okay,
So.
all right. So Rohit is somewhere in Iceland. He's also
At the University of Iceland, yeah.
Yeah, and he's a researcher there, but he will on occasion also make your acquaintance. So in other words, you have as much as you have Rahul for a professor, you have a very interesting cast of characters.
Way more interesting cast of characters than me, I can tell you that.
So take advantage of that. Ping them often, harass them. I mean, in a manner of speaking, not really. Right, learn as much as you can from them. Hopefully during office hours, primarily though. But they're wonderful people, and on their way to do amazing things. So hopefully, will be of a lot of use to you, not just for this course, but also as kind of a direction finder for things that you might want to do in the future. So before we wrap up this evening's session, I just wanted to introduce you to this idea of breakout rooms. Many of you might be already familiar with it, but what we're going to do is once or more during a lecture session, we're going to do labs. And the way we will do is that instead of all of you signing out and then signing back into a different session headed by a TA, what we'll do is we'll move you into breakout rooms, each of those headed by your respective TAs for that particular day. And they will take you through a lab, right? And Rahul will tell you little more about how a lab runs before you actually experience it. But what I wanted to do was to have everyone do a little practice session on breakout rooms. So I'll give you a primer. What's going to happen is I'm going to move according to a list that I've already decided, all of you into two different rooms. Now, we'll also assign a couple of TAs each to each room so that each room has one or more TAs, right? And under ordinary circumstances, there would already be an agenda and you guys would be doing something in those rooms. But this time it'll just be for the sake of movement and back. Now, once you are in a breakout room, your point of contact at that point is just the TA. You can send out a message to the host, but I don't think in our particular case that's of any use, right? And then it turns out that a breakout room does give you an opportunity to return back to the main room anytime you want, except that we will probably not be using that facility. I mean, our sessions right now are not designed for free back and forth movement between the main room and breakout rooms. But at some point, that might be useful. For example, if you were doing something in a main room and you were doing, let's say, if you wanted to consult your TA, you could duck into your breakout room, consult your TA, and come back. That's a feature that Zoom offers, but we won't be using that. So what we will do is you'll go to a breakout room, you'll do your lab, and before the time ends, when you are required to come back to the main room for the classes to continue, there'll be a warning from the professor or the host of the session onto your screen. Your TAs will also be there, so they'll also warn you, at which point you need to wrap up your session and head back out into the main room. So simple enough, yeah. And while you are in the breakout room, obviously you can get messages from your host and your prof, which is how you will find out that you need to get out of there. And right now, what we will do is, as many times as we have breakout sessions, we'll actually close the breakout rooms, right? There's an alternate functionality like I was talking about, when you can actually leave your breakout rooms open, but we won't be using that right now. And if we do, then we'll change that policy going forward. So what I'm going to do right now is going to push uh, all of us into two groups, not too many. And then what we'll do is I'll visit each room, say hello, come back out, send you a message saying that we are about to close the rooms, and then dissolve the breakout rooms, which will force all of you back into the main room. Now, one thing to sort of note that if you exit the breakout room before the session actually ends and you say leave room, it gives you two options: end meeting or leave breakout room. Please always choose leave meeting. Okay, and I'll show that to you in your respective breakout rooms. But if you say leave meeting,
what are you saying? We don't want people to leave the meeting.
What did I say? I said leave
said
meeting
leave
and not
meeting.
breakout room.
Yeah.
Okay, I'm sorry, I take that back. Always leave breakout room and never leave meeting. Or better still, just wait for us to shut the breakout room and you don't have to do anything else, right? You will automatically land up in the main room. Okay, so with that, get set, go. We're going to pump roughly half of you into one room, which is how also it'll happen in subsequent sessions. So here goes.
Hey guys, can you hear me?
Yeah, Rahul.
We can hear you. Sir, you are audible, sir.
Oh, good. So we're in a breakout room, and I don't know how many of us are here. There's some fraction of us in here, maybe about 11 or 12 of us in here. And the way labs will generally work is that we'll work together in a room with the TA, and actually work on code. Each one of us will work on the code on our own. And then at some point, we'll sort of like see what the answer of that code is, and the TA might actually explain it. The idea behind the labs is essentially that you are actually working on Python code in the context of the lecture, in the context of of what's going on in the lecture. So it's not like you're going to be writing too much code from scratch. It'll be relatively less code to write. Kind of more of a fill in the blank style, if you like, than anything else. So you'll write that stuff there, and then you'll see what answers you get, and then we'll have a little bit of explanation. And the whole idea behind it is that you're actually getting to practice a little bit whilst you're in the class, so that when you go and do your homework, you're not feeling like, oh, where do I start? How do I do this? Stuff like that. So that's the basic idea. Akshaj, is there anything you'd like to add?
No, I mean, if they have any questions for like the whole course, I think we can answer that right now, right?
Yeah,
Do we
yeah.
have?
If you have any specific questions, we are in a smaller group, so feel free to ask.
Good evening, sir. So
Good evening.
could you please elaborate more on the final project we'll have? What does it entail?
Yeah, so the final project is actually going to be the same for everyone in this case. You are going to use the library
So,
called
Rahul, are
Kudzu.
you going on with your session in the breakout room?
Yeah, we're taking questions.
Oh, excellent.
Yeah. So what we're going to do is we're going to go on with our Kudzu library. Or we're going to do two things. Literally, like question one is going to be about doing a regression problem using the Kudzu library, where you're actually going to do a nonlinear fit of a manifold to some complicated looking data.
So Rahul, be prepared to repeat this because I'm going to kill the breakout rooms in about a minute and you'll be out.
Yeah, okay, kill it in a minute. But no, this is just for questions that have been asked. People can ask these questions on Slack. So then the second part of the project, you're actually going to classify numbers using the library that you wrote on your own. So, normally when you do this in a kind of like in a machine learning or a deep learning course, you'd use Keras or PyTorch or something like that to do it. In our case, we actually want to teach you how to write Python to do this for two reasons. Even though you will actually probably end up using PyTorch or Keras. One is we want to get you to the level that you can actually write code that goes into PyTorch or Keras. B, it's always good to implement algorithms on your own. So that's why we're going to do it in this fashion. Make sense?
Right, sir. Thank you, sir.
Cool. Any other questions before Siddharth kicks us out? I think he does give us a warning before he kicks us out, so we can go on and take more questions. Probably too many. I was wondering if you could do a little bit of an introduction session. No, he's kicking us out in 30 seconds. Oh no.
During our working session, are we going to look at the intuitive part of the maths like Jacobian or say?
We'll be looking at different parts of maths in the lecture as well as the interactive sessions. So yeah, absolutely.
It's going to be like a working on implementation or understanding what does the.
So the lecture part will be understanding, and then the lab part will be implementation.
Okay.
Lab and homework, frankly. Okay, I think we're all back.
Yeah.
Or no?
Yep, looks like it.
Looks like we're all back.
Mm-hmm.
Super. So any questions about the process, folks? About this breakout room process? Reasonable enough? Makes sense? Yes. Yeah, okay. So what I'll do very quickly now is to take 3 or 4 minutes and show you a little bit about the platform that we have. You probably get access to this platform in a day or two. You'll get access to the GitHub repositories before the platform, but I just wanted to take 2 to 3 minutes and demo out the platform to you before we split up for the day. Let me just do that. Let me share my screen. Share this desktop. And where did I keep it? Firefox, is it on Chrome? Here we are. So you can probably follow along in your browser if you like, or do it later. It's courses.univ.ai/Python starter, I think. So this is actually not our course, but it has portions of our course in it. It's just a bunch of stuff for people who want to learn Python on their own. So if you want to play around, feel free to go in and play around with it. So this is the Python starter web version over here. Some idea. A lot of it is just sort of like just to test things, but I just wanted to show you the platform so you can see it. You'll have a very similar platform ready for you by either tomorrow or day after, which you can then use for our class. So for example, say we wanted to talk about the basics of Python, which is what we will be talking about tomorrow. So you just click on that. I went a little bit too far. The basics, yeah. There we go. So here's just some filler stuff out there. That's your usual lorem ipsum. I think this is from the Raven, but I'm not sure. So this would be kind of like a chapter. A chapter is basics, and getting started is a section in the chapter. And this part of the thing, getting started, corresponds to a single GitHub repository on GitHub. So if I click on it, you can see what's in this GitHub repository. If you click on the downloads, you can go to it on GitHub. It'll open up in another window. And this is the GitHub repository for you. And you'll see that there is a getting_started.ipynb notebook, which you can play with. You don't know how to use GitHub as yet, and we're going to teach you how to do that. But you can always go on this green button which says clone and download a zip file of whatever is inside these folders for yourself. So if you want to play with it, just get started doing some stuff, that's a great way to do things. So you'll always find there are notebooks of two kinds. One is getting_started and the other is distribute getting_started. Getting_started has all the results of the computations in it. Distribute has no results. So if you're the kind of person who doesn't want to see what the answer is before they start doing something, use the distribute. If you're a person who wants to see what the answer is, use the other one. Okay, so you can follow the code of what's actually going on right over here. So there are slides over here. These slides, I think I maybe need to just reload it. Having some problem with my browser. Okay, no, I think there's some problem over here. Let me go further down. So getting started with Python, this is the notebook. It's just basically using it as a calculator. Then it talks a little bit about variables. Then it talks about variable data types and different kinds of things over there. And so you can actually look at it right within this interface. So if you go to listiness, tells you a little bit about using things as lists in Python. And so you can look at this at your own leisure. Different functions, all kinds of stuff in here. And it's at courses.univ.ai Python starter, and you can do stuff there. You can move things around over here, and you'll notice that if you are in a, you can pin this, and when you pin it, stuff goes below. And as you move down, let me move this down a little bit more. For example, let's get to variables, I think. Iterating over lists. Strings. Notice when I move to strings, the slides move off to strings. Was everybody able to see that?
Can you please repeat that part?
Yeah. So as I move myself down in the in this file, you should be able to see that I'm kind of moving down the notebook over here. And as I move myself down, things may or may not move depending upon which slide you're on. So for example, I moved back up to lists. So my slide goes on lists. And the idea behind this is that the slide itself is going to give you some kind of summary of what's going on, what we're talking about, whilst the detailed notes are in this user interface below. We'll go into this in more detail, but I just wanted to show you. Here we go. And you go all the way to the top, it goes back to the first slide. And this is in this pin down mode where these things are connected to each other. If it's not pinned down, they're not kind of connected to each other. So that's all. I just wanted to kind of show you that. And we'll have this on. See, as you can see, it moves when it's pinned. Here's moving to strings, and that's where it ends. So you can sort of like bidirectionally go from one of these to the other in the platform. And we'll have actually put our course into the platform starting tomorrow as well. Something else about this that I wanted to sort of introduce you to is I think going to be there. Let me go to Python Spec to Python Startup course here. Oh, something happened here. Oh, it's Python Startup, not Python Startup course. I think typing something wrong. Yeah, sorry for that. I forgot the name of my own course. That's not a good sign. Developing code and testing. Software development over here. This is the place where we're going to actually talk about software development. So you're going to see that what we're doing over here is we're going to start with writing everything in a notebook. And then we're going to go into subsequent versions of this kind of vector file where we add some tests. And some code, which is then used in notebooks further in the notebook further on as we go further down over here. So there are different sort of like nice little kind of user interface things we have in over here that you can actually use. You can download all these different files right from this user interface if you like. You don't necessarily have to go to GitHub to do it, but sooner or later you do want to get comfortable with GitHub. So let me stop sharing. The idea behind the platform is twofold. One is you can follow along in the lecture while we're talking about things, while we're talking about notes and so on and so forth. But actually, more importantly, and this is kind of important for you, after the lecture is over and you want to go back and you want to look at notes and you're going to say, oh, he talked about something on that particular slide. What was he talking about? You can go and see the slide together along with the notes that go with it. After lectures, we're recording the lectures. So after lectures, what we'll end up doing is we'll end up actually taking the segment of the lecture that corresponds to the segment of the slides and that corresponds to the segment of the notes and put them all together synchronized so that you can actually say, hey, I actually forgot what Rahul said about strings. Well, let's just go to the string slide and then it'll actually start, my talking head will come on and start talking about strings from that point onwards. So you can go to exactly the point of the lecture you want to and listen to me from that point onwards rather than having to hear me drone on for a very long time. So hopefully you'll find that kind of useful to be able to go through things in a kind of pick and choose fashion rather than just have to figure out where I was exactly in the lecture. So small little user interface things which I hope you'll actually find useful. And then finally, there's one last thing I wanted to bring up is that we've invented a new kind of collaborative editor. We're calling it NBPad. There's a little note about it in the welcome.univ.ai thing. It's not yet up on the site, but it will be in the next day or two. And we'll be using that quite often in the what's it called? In the office hours. Let me actually see if I can share my screen. For that, hold on a second. Let me just do that. I'll share my screen, share my desktop, go to Safari, and go back to the welcome over here. Go back. I think this is my main page, right? This is my main page. Education software we use. Here's NBPad. And I can only show you pictures instead of demoing it because I don't have it, but it's essentially the kind of place where you can just upload a zip file or a notebook in there. And then multiple people can collaborate on the same notebook over here. So here, Alice and Bob are collaborating with each other on this screen. And both of you will be able to edit the same file, the same notebook at the same time. Why is this useful? Suppose you've done something and you're not getting it to run for whatever reason. So all you do is you upload it into one of these little things, talk to your TA or talk to me, show us this. We can hop in and edit with you the part that we think is not making it work. There's a run button out here. When you run it separately, the teacher runs it separately, or you run it separately and the friend you're collaborating with runs it separately, so that you don't clobber each other's Python processes and see what's happening separately in it. But the code is identical. It runs the same code on your side, and it runs the same code on my side. How on earth do we do this? We don't run either of these codes on your machines. We run them on a cloud-based server, but they run as separate Python processes. And so if something is not working, your TA or your professor or a friend can help you fix it, and then you get it working, and then boom, you can copy it into something else. There's also functionality in this to start a video conference with everybody who is on the call over here. So you can actually talk to each other while doing this, rather than necessarily just have to do it kind of quietly with each other. So it's another little piece of software written that will help you. So there's like two completely new pieces of software you won't find anywhere else, which at least I think are fairly interesting, both the platform and this. And I think hopefully both of those will actually help you in your learning process. So I just wanted to introduce those really sort of like a little bit on. And as we go on in the course, we'll see these pieces of software in more detail. I also want to mention that both the platform and the NBPAD software are completely new. You've probably seen our exercise and test system if you did our exercise, if you did our scholarship test. So you may have seen that one, which is also fairly new. So it's likely that these will break from time to time because we're kind of adding new features on them every day. In a sort of agile fashion. So bear with us a little bit on those. I think you'll find that your experience gets better over time, and that these pieces of software actually have very sort of like newish educational software ideas that you won't find anywhere else, which will actually help you in your learning process. So yeah, I think that's what I wanted to say about it. And let me just look at my list. I think that finishes everything I wanted to talk about today. Siddharth, do you have anything else you wanted to add, or Varshini or anybody else on the teaching staff? Please feel free to jump in.
I want to know a little bit about everybody's background, but if we have too many people to actually do a go around the table here, so I'm going to propose an alternative. We'll circulate a type form where you can write a little bit about who you are, what brings you here, what are your learning objectives, and if there's anything particular and interesting about you that you'd like to share. It'd be nice to know you. And I think over smaller sessions and during QAs, we'll get to know you a little bit better. And
yes,
I think
yes, absolutely. And let me add, please, in the water cooler in the water cooler Slack channel, please introduce yourself.
Okay, so then we'll still circulate a form though, so that
form is kind of nice because
yeah. All right.
What I would actually love to have is an app, a form app which lets everybody take a picture of themselves and put that in, so that we can start recognizing, putting sort of like names to mugshots, as it were, of people.
Let's see if we can pull that off before the end of the class. So then I think which essentially means that all of you keep your mugshots ready. We'll have you slap it somewhere. Though I guess and hope that in the TA sessions we'll see you on video. It's less fun just seeing a name card on the screen.
Right. Yeah. Exactly my point over there. Feel free to use that Jitsi functionality, which is there in the Slack as well, so that we get to see each other. And please introduce yourself in the Slack channel. And if you're not yet in the Slack channel, please get into it so that we can continue the conversation. Over there.
So apparently you can add photographs in type forms. So we'll look at that and circulate it. So if all of us do this, then we'll create like a class book, and everyone will see everyone else
Okay,
and know
super.
them. And maybe before the end of the class, maybe you'll have a few friends also from a completely online environment. So let's see how that goes. We look forward to that.
Siddharth, I was
Yeah.
thinking that like I can host a mixer session where if people are interested, they can join it and like just for basic communication and introduction with each other.
That's a great idea. Go for it.
Yeah. So can I
Yeah.
just get a general vibe? Are people interested? If you're interested, then just raise
Akshat,
your
there is
hands.
a huh? Yes. Yeah. Let people answer here.
Yeah, if you're interested in the mixer, then just raise your hands.
No, they're pinging it on the chat.
Chat.
It's on the chat.
Okay.
Yep.
Yeah, okay, cool. So people are interested.
So there's
Okay.
8 yeses, 9. So I guess you'll have a small online party, Akshat.
Yeah.
It's good. All right.
So Akshay, just post about it on Slack. But
Yeah,
everybody
I
else,
will start.
don't forget tomorrow 7:30. And Siddharth, what's your plan to send out the Zoom coordinates for that?
I will. I'm trying to see if we can have a single Zoom coordinate for the rest of the meetings. And
That would actually be
way-
fabulous. Make it just a recurrent
Yeah.
meeting, right? On Thursdays
Yep.
and Sundays at that time.
Yep. So
Okay.
either which ways, you'll have a meeting link in your emails as well as your Telegram.
And on Slack.
And on Slack sometime tomorrow morning. So take a look, and then we'll see you tomorrow. And feel free to post questions if for everybody else non-academic on Telegram if you need help, but everything else post on Slack.
And please fill in that form. Important. So let me just one last reminder before we head out. Get your GitHub account. Connect your GitHub account to the Univ.AI account. If you don't have a Univ.AI account for whatever reason, email us at Telegram us and we'll set you up with that. Or Slack us and we'll set you up with that. So do the GitHub, do the discourse, and fill in that form so I can add everybody to the appropriate places before the class tomorrow. Thank you. Oh, and do the Anaconda install before class. Yeah.
And one little sort of note from previous sessions experience that unlike in a live class, if you don't do the things that are required before the class, you will rapidly fall behind and this won't be fun anymore. Right?
Yeah.
So I think just so that you have fun, irrespective of anything else that happens, please do basic setup stuff, right? And maybe what we'll do is tomorrow's session even before tomorrow's session, I'll get a checklist from all of you. So as you finish, I'll try and figure out, get a scorecard on how many of you finished your basic setup. All right. So thank you everyone for coming.
Prasanna is asking, will a recording of this session be available? Yes, it will.
So where are we posting the recording? We'll of course post you a link to the recording on YouTube, right?
Yeah, this one will be on YouTube.
Okay. All right.
Subsequent ones we have to figure.
Okay. All right. So good night, everybody, and talk to you soon.
Good night. Thanks, everybody.
Good night.
Thank you.
Talk to you tomorrow.
Good night, sir.
Bye, guys.
Good night.
Thank you for joining.
Thank you.
Bye.
Thank you, sir.